All right, we are going to move on to our next step in factoring, and we're going to use a technique called grouping. And so within grouping, we're going to have a 4-term polynomial, and we're going to be able to group it into 2 binomials. We're going to be able to find the GCF of each term, which we know how to do that. We also know how to divide out the GCF, and then we're going to take it that next step, find the GCF binomial, and then understand and explain the commutative property of multiplication in this lesson. So by the end of this lesson, you're going to be given 2 4-term polynomials, and you are going to factor them by grouping. All right, before we get started, I would like for you to practice factoring a GCF. So go ahead and pause the video and factor these 3 problems completely. All right, so look over these answers and compare it to yours. Write down any questions that you have. Hopefully you are able to factor these 3 completely. All right, so we've talked a little bit about factoring and how it connects to what we were doing previous. So if you'll just pause the video and in your own words, what is factoring? All right, so as we move into this next step of factoring by grouping, these are the 5 questions that I ask myself as I'm working through this process. So how can I group the expressions into 2 binomials? What's the GCF of each binomial? When I divide out the GCF, what remains? And do the binomials have anything in common? And when I divide out that binomial, what remains? So that seems like a lot of words and kind of confusing, but once we start applying it, you will catch the hang of it. All right, so let's go ahead and get started. So the first question is, how can I group the expression into 2 binomials? Well, there's 4 terms, so I'm going to group the first 2, and I'm going to group the second 2. And one thing I want you to notice is I grouped the sign with this 3rd term, so make sure you pay attention to that. So I've grouped them into 2 binomials, and then what is the GCF of each binomial? So when I look at a to the 3rd and 7a squared, they don't share any number greater than 1 because the a to the 3rd has just a coefficient of 1, but they do share 2 a's. So I'm going to take out an a squared from the first one. And then from the second one, they share a positive 3 because remember, we always want the first term to be positive, and so that applies to this as well. If this were negative, then I would take out a negative 3. All right, so I found the GCF. So when I divide out the GCF of each binomial, what remains? So I took out an a squared. So a to the 3rd divided by a squared gives me a. And then 7a squared divided by a squared gives me a positive 7. All right, and then over here, I took out a positive 3, and so what remains, 3a divided by 3 is a, and then 21 divided by 3 is a positive 7. And so this is my next step of what remains. I get those 2 binomials. So do they have anything in common? And so what I mean is, does this have anything in common with this? And hopefully you notice that they both share an a plus 7. So they both, I'm taking out of both of those that a plus 7. So when I take it out, what remains? Well, I'm left with a squared and a plus 3. And that is my answer to that factored polynomial. So I want to review really quickly. The first thing I did was I grouped it into 2 binomials, and then I took the GCF out of each binomial out. And if you notice, that is what ended up in this second binomial. And then when I divided out the GCF, what remained is what they shared, and that became my other binomial. So remember, factoring is undoing that distribution. And so if I were to multiply this back out and combine like terms, I would end up with this polynomial original. One more thing that I want to bring up is that multiplication is commutative, so the order doesn't matter. So you might also see this answer if you got a squared plus 3 times a plus 7. Those mean the same thing. So as long as the binomials are paired correctly, the order that I put them in doesn't matter. So just keep that in mind. All right, so let's start with this example, 32k to the 3rd minus 56k squared plus 20k minus 35. How can I group it? Well, I'm going to put this and this. All right, what is the GCF of each binomial? So 32 and 56. So they share, the largest number that they have in common is 8. And then k to the third and k to the second, they both share 2 k's. All right, and the other one, 20k and 35, so 20, the leading coefficient is positive, so I don't need to take out a negative, and they don't share any variables, so I'm going to take out a 5. All right, so when I divide out the GCF, what remains? So I took out an 8k squared from the first one, and so when I divide that out, I'm left with 32 divided by 8 is 4, and k to the third, and I put 2 k's out front, that leaves me with a k. And then negative 56 divided by 8 is minus 7, and I had 2 k's, and I put them out front, so that's what I'm left with. And then over here, I took out a positive 5, and so 20k divided by 5 is 4k, minus 35 divided by 5 is negative 7. And so do they share something? They do, which is what I want. They share a 4k minus 7. And so when I take that out, what's left is 8k squared plus 5. And so that is my factored form of example 5. All right, so what I'd like you to do is go ahead and pause the video, and I'd like you to try the first 2 questions on your own. So how can I group it into 2 binomials, and what is the GCF of each binomial? All right, hopefully from the first you were able to group them as 7m to the third minus 8m squared, and then the other binomial, negative 28m plus 32. And then what is the GCF of each? The first one, they don't share a number larger than 1, so they don't have a coefficient other than 1 in common, but they do share 2 m's. And then in the second binomial, I'm going to take out a negative 4, because I always want that first term to be positive, and negative 28m is not, so I take out that negative 4. All right, so let's continue. So when I divide out the GCF, what remains? So m squared is what I took out, and that leaves me with 7m, and then minus 8, because I took the 2 m's and put them out front. And then in this one, I took out a negative 4, and so when I divide out a negative 4, I'm left with 7m, and 32 divided by negative 4 is minus 8. And so do they share anything? Yes, they do. So this is a great way to check and make sure that I've factored the largest GCF out. They share the 7m minus 8. So what's left is m squared minus 4. And that is my answer. All right, so what I'd like you to do right now before we move on is I'd like you to just pause the video. I want you to reflect on what we've done, list out some be sure to's, write any questions that you have, any hints or things that you're going to need to remember if you want to make a list of steps, but just have an interaction in your notes right now. All right, so I'd like you to pause the video, and I'd like you to try example 7 on your own, see how far you get, and then check your answer. All right, so when I factored this, I got 8b minus 5 times 3b squared plus 8. All right, go ahead and try example 8 on your own. All right, so for this one, when I factored it, I got 7x minus 2 times 8x squared plus 7. So if you didn't get that, go ahead and look over my work and identify any questions you might have. All right, go ahead and try example 9 on your own. All right, so for example 9, hopefully you got 7b plus 8 times the quantity of 7b squared minus 5. If you didn't, go ahead and look over my work and identify any questions that you might have. All right, so for the remaining examples, we are going to discuss those in your CSGs tomorrow, so be prepared to work those out. All right, so we've come to the end of this lesson. What are 3 mistakes you think students tend to make when factoring by grouping? What are your be sure to statements? So what are you going to need to remember? Where were some mistakes that you were making? And what questions do you still have? So go ahead and reflect on your learning, and I will see you tomorrow.